This question is from the Instrumentation Engineering paper for GATE, and it belongs to the Sensors and Industrial Instrumentation module. So this is a question from the Flowmeter section, and the question is stated as follows. A differential pressure transmitter of a flowmeter using venturi tube reads 2.5 into 10 to the power 5 Pascal for a flow rate of 0.5 meter cube per second. The approximate flow rate in meter cube per second for a differential pressure of 0.9 into 10 to the power 5 Pascal is 0.3, 0.18, 0.83 or 0.6. So this is a typical question that uses the basic relationship that we are already aware of for a differential type flow meter, which is that the volumetric flow rate Q is directly proportional to the square root of the differential pressure drop across the meter, which is the difference between the upstream and downstream pressure. So that's the delta P. And therefore we can represent Q as K times square root of delta P, where K is a proportionality constant. And if we refer back to the question, they have given us the value for the differential pressure. So this is the value of differential pressure, 2.5 into 10 to the power 5 Pascal, whereas the value for the volumetric flow rate is given by 0.5 meter cube per second. So if we substitute these values for Q and delta P, we obtain the value of K, which is equal to 0.001 numerically. And then the question now wants us to know what should be the value for the flow rate if the differential pressure changes to 0.9 into 10 to the power 5 Pascal. So if we refer back once again to this equation, Q is equal to K times square root of del P. We have already found out the value of K, and the value for delta P is 0.9 into 10 to the power 5 Pascal. So if we substitute them and solve for it, the answer turns out to be 0.3 meter cube per second. So option A is the correct answer for this problem.